Good afternoon, ladies and gentlemen, and welcome to the SAIEE Kwa-Zulu Natal Centre webinar today, where we'll be discussing leveraging regressions on the path to lean energy. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on their device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV. The recording will also be made available on the SAIEE website under the events drop-down menu in the section past events and webinars. This page is updated regularly, so ensure you check back as often as possible for new uploads and subscribe to our YouTube channel. A certificate of attendance will be issued a few weeks after this webinar once we have received the CPD validation number from EXA. I'd like to introduce you now to our host today, is Mr. Shepherd Nkosi. He is the SAIEE Kwa-Zulu Natal Centre Chairman. He holds a Bachelor of Technology degree in Electrical Engineering, a post-degree with USQ, University of Southern Queensland, Australia, a post-degree in Project Management with the University of Stellenbosch, and is currently completing his Master's degree with UKZN. As I mentioned, he's the chairperson of the SAIEE KZN Centre and, of course, served as Vice President of the Durban University of Technology Advisory Board and is professionally registered with EXA. I hand you now over to Mr. Nkosi.
Thank you so much, Ms. Afrobus, and thank you also for the introduction. We warmly welcome everyone who's connected this afternoon. I'm pretty sure we are all looking forward to this afternoon presentation, and the theme, as indicated by Ming, it is leveraging regressions on the path of lean energy starts. I think this is a very interesting topic for all of us, and we look forward to our guest speaker this afternoon. And maybe a quick introduction of our guest speaker. We have Kyle Rossi, and Kyle has been active in the energy industry for more than 13 years. Kyle has used energy software with a different head as an end user, and is part of the Peru team, and finally in a consultative commercial environment. He worked with a few global companies, assisting them to achieve their energy goals. He understands that clients have different needs, whether it is based on a specific industry, country, or niche, based on any individual business. Please join me in welcoming Kyle, and I'm sure we'll enjoy the presentation. Kyle, over to you.
Thank you very much, Shepherd. I'll just share screen there. So yeah, thank you very much, Shepherd, and thank you for the opportunity to present today in front of the members of the South African Institute of Electrical Engineers. Yeah, I really welcome the opportunity, and I want to share some insight today. So just a sort of brief introduction of eSite Energy. We are a global energy management software company, and we help businesses reduce their energy cost and carbon. It's a system that is available in 17 different languages, and it is multi-currency. So I just wanted to share with you our mission statement, and it sort of really does sort of show what eSite is all about. So what we're looking to do is centralize data from all data types. So it's not just around energy data. Again, as part of the presentation, I'll discuss it further, but it's about adding KPI information such as production information or any data relating to sustainability to help build that full reporting purpose. Additionally, what we're looking to do is be able to pull data and receive data from any source or system. We've been in business for 22 years, and we've been adapting to the industry and the technologies, and we're continuing to do that in the future too. And just the last point on this slide really is that we are sort of committed to providing sort of powerful analytics, and you know, being that globally sort of best in class. So just essentially, just want to make sure that, you know, we've got the right people and for the focus of today's call. So today's session will be a really good fit if you're responsible for energy efficiency within your business, or if you're working with energy efficiency on behalf of your clients. If you manage a portfolio of buildings, or if you just want to gain a further insight and knowledge in terms of regression analysis. So one of the things that I'm continuously impressed with is how tools have developed over the years, and not just with you know, the tools within eSite, but any tools that sort of provide you with greater insights. So we're going to look at how we apply linear regressions as a precursor to multivariable linear regressions. We're also going to take a look at how those insights and how we create those insights on the result of using regressions analysis, primarily on consumptions. Today's presentation, although I'm referencing cost there, I'll be showing the graphics within sort of consumption, but within the eSite system, it's easily converted into cost using the rate schedules. It's quite a simple process. Additionally, we want to look at what we're doing with eSite Energy and how we can make the tools available to add to the skills that you know, clients and future clients already have. And lastly, there'll be time for questions at the end, so we can sort of field those accordingly. So just, I guess, a brief introduction on myself. I know Shepard's already gone through this. So I've been in the industry for 13 years now, as Shepard mentioned, a number of different hats. So I'm not just in the commercial selling energy software. I've been part of bureau teams, doing multiple different energy reduction projects. I used to work at Schneider Electric in my previous role. So here at eSite, I'm managing the sales teams in the EMEA and APAC region, and I manage the global accounts, or I account manage the global accounts. My email address is there at the bottom. If you do have any further questions after today's event, feel free to get in touch. So we want to use procedures or business procedures that already exist, and apply this to energy management. So I know a number of you will be familiar with Six Sigma. However, fewer people will be more familiar with the theory of constraints, so TOC. This is the work of Eli Godrat, and he supported lean manufacturing and conceptually various thinking processes that help us on the path to ongoing and continuous improvement. So I've taken from lean manufacturing the basics of define, measure, analyze, improve, and control, and then I've extrapolated them to a concept of lean energy, very much in line with the 5 focusing steps of the theory of constraints. So this gives us lean energy. So from a defined perspective, we want to start those governing measurements with the independent variables that we can use and to relate against our consumptions. So if you're in a manufacturing environment, then it's obviously going to be production. If you're in a building management environment, then it could be building population. And this is one of the great variables that we're constantly chasing after in terms of regression analysis. It could be temperature, humidity, or extrapolating that to degree days or heating degree days or even cooling degree days. Seasonality or what day of the week it is. And then related consumptions. So one of the conversations that I have with clients is really difficult to get an accurate number of people within a particular building. So whether you're a manufacturer or in the building management environment, it does become quite difficult. A lot of us were thinking, you know, along the lines of CO2 concentration, so using that as a measurement to be indicative of that building population. At the same time, with COVID, air exchange for all buildings is suggested to be dramatically higher. just so we're breathing clean air. So the benchmarks that we may have in terms of setting that for CO2 concentration are going to make it even more challenging. So as a result of that, I do recommend, related consumptions. So this could be, for example, when the people are in the building, that they're washing their hands, using the restrooms. So you could use water consumption as a correlation variable in regards to building population. At the same time, we need to continue on and measure that relationship in terms of, once we've established those independent variables and established that relationship, we want to look at the measurement between what we are predicting as a result of the building some regression and then what we end up having. So the system is under control. And we're going to take a look at that at different intervals of time to make sure that we can understand if the system is under control. So we're repeating that process. Just again, an example, if you're looking at a hospital emergency room, there's going to be no individual daily patterns. So there might be some day of the week patterns. And then you can get, where people sort of get stressed out on Mondays and they sort of go to the hospital, etc. So there might be a spike in consumption there. So you can add all these variables into the regressions. So, what we can do is, use the extrapolations in the interval analysis, and these might be daily, or these might be seasonal based on your business. Or you might want to be able to understand your system is under control at even higher frequency, such as 15 minutely, but then you need to have a good traditional flow of consumptions. As we analyze those relationships between the independent and dependent variables, you're going to implement energy conservation measures, which will then have the potential for changing that relationship. So we need to be able to update our regressions based on the energy conservation measures that you've created. And this is a key part of that continuous improvement and being lean with energy. So if you want to implement these improvements, we need to monitor those relationships and make sure the system is under control and make sure those updates have been made. So on a basic single linear regression, we're really looking at how a driving force tracks related consumption. So in this example, we have package volume alongside CO2 consumption, which is a production extrapolation from a beer manufacturer that we work with. So if that correlation and the relationships between the driving factors and the consumption is good enough, we can potentially use a single driving force. And this is where you do the single linear regressions. So linear regressions are going to take the shape of a formula that we all sort of learn in school, so in terms of algebra. So this is y equals mx plus b. So y is the dependent meter, and this is potentially electricity consumption, water consumption, natural gas, for example. And how does that relate to the independent variable? So for example, again, the actual production in a manufacturing environment, or the population in property management, or potentially the water usage in property management. And then ultimately at the same time, your independent variable is 0. We need to try and understand what's going on or what's going to happen when you're not producing. So understanding if there is a base load in there and taking a consideration of that. As a result, we create a line of best fit. So this is a scatter plot. And once we've established those data points, we're going to we can then indicate and then use various methodologies to create that line of best fit. So once we've established that line of best fit, we can then establish that equation. And how does your consumption compare to that package volume in this case? And what does that slope look like? At the same time, that line of best fit would challenge our thinking, and in terms of making sure that we are obviously going to exclude behaviors that we don't consider best practices. So the line of best fit does in fact represent our best practices. So that what's going to happen, what we're looking to do is make sure that if we've pulled all the independent variables, that we have measurements for, we need to be able to determine very clearly what our consumption should be. So for that reason, that is why we're excluding those outliers. And when we happen to leave a large door open so that we're air conditioning outside, for example, or even if we're running something new in the building and we don't quite understand those relationships yet, those outliers could be excluded. At the same time, that line of best fit, when the independent variable turns out to be 0, that intercept represents our baseload, as I mentioned before. And I know that these concepts are pretty familiar with the people on the call today, but I just want to make sure that we're all on the same page in that the line of best fit represents our best practices, and that we know that the intercept represents our baseload. So in terms of extrapolating to multi-variables, the measurement correlation is R² values, and this ranges from 0 to 1. Our multivariable regressions track against the IEP, MVP, and ASHRAE guidelines, and anything above 0.75 is a good statistical correlation. At the same time, we need to make sure we have enough data. So we're not just doing this off a data set of 3, 4, 6 data points. We need to really be extrapolating a lot more to ensure there's enough observations to get that good statistical correlation. At the same time, as I mentioned earlier, we can easily extrapolate that to multiple variables, and what we can really start making is all the measurements that are going to help us understand what is driving consumption. So is it humidity? Could it be humidity along with degree days, or solar irradiance, for example? These are all variables that are driving our consumption and that we're going to try and make our understanding. So my point being is that regressions really do represent our best methodology for creating dynamic targets. And from the perspective of eSight and our capabilities, we had a powerful multivariable linear regression, or MVLR engine, and we're now just going to start calling those regression models. But it's been a powerful engine. And do we really need to change? At the same time, in business, the business is of change, it's continuous improvement. So we're committed to trying to make not only more powerful analysis tools, but also making it faster and easier. And we want to be able to make our clients using the software, not managing that software, but really using the tools to drive that business forward in terms of that energy reduction. So why do we want to change? So previously we were creating regressions one at a time, and tuning them was a real process. You had to do that single-handedly. And we want to separate, we had a separate interface for the single linear regressions that had one variable, and it gave a lot of powerful insights, but this wasn't available in the MVLR engine. Also, in terms of the validation and analyzing that regression, you're back and forth between different areas of the system. Some of the visual tools were not available on the MVLRs either, and in terms of the MVLRs, they're only limited to 10 variables. So as a result, I'm here to share with you the new capabilities of eSight in terms of regressions. So we can now support up to 20 variables, and people may ask, why do you need so many? Well, one of the things that I've been learning and introducing different meters is that even to represent a day of the week sensitivity or seasonality, these variables can be introduced, and as a result, they can take up some of those measurements. At the same time, in terms of validation tools, when you're looking at the model, you're simply one click away now from being able to validate that and looking at the relationship between the complete regression or even the individual variables. From a data exclusion perspective, we've always been able to program and essentially establish boundaries and say, if the temperature shows lower than -60, then exclude that. If the consumption is negative, exclude that. But we've also introduced a new data exclusion rules like ranges. So if it's within or outside a particular range, exclude that. We've added more statistical information to our insights as well. And then as well as that, we're being able to select both your independent and dependent variables based upon tags. Tags within eSight are utilized more and more, and this allows greater flexibility and quicker configurations, within regression models and just standard energy analysis. So now by allowing that flexibility, it allows for the system to build these regressions en masse. Now building one takes the same time as building 1,000. And essentially you're building the building process, at which you're going to go into a moment. You can really sort of make those available in your analyses as well, which again I'll show you as well. Okay, so just to jump into a bit of a live demonstration, just so you can see that then. So what we've got here is the eSight Express user license, and we've got eSight 2 user interfaces. They do work hand in hand. So this is the more casual user experience. It's very easy to use. Users of this UI are basically gaining all of that good information that the advanced user license would provide. So with the advanced user license, you do all the configuration in there, and you can deploy to this UI for your clients potentially, or your site contacts. This is very easy to use. You've got the sort of side panel down the side here, and then you've got access to your information instantly. But for today's session, we need to go into the advanced user access, and this is where you do all the configurations, as I said. So we're going to start with, we're going to go into regression models. And then we're going to pull that path back actually. So with the regression models that we had in the system prior, they'll be listed as sort of full view here. Where we're introducing sort of new versions of those models, they will be then time-stamped. So they're actually time-stamped, so you can actually understand, is this the current model? Is this V2, V3? So if you're doing multiple projects on a site, you can have multiple regression models in play. So what we're going to do is just go into master data regression models. Just what I want to do is show you how easy it is to set up a regression model. So we're just going to click into edit mode here. What you can see from the side panel here is a process, wizard, or workflow. So we've got 5 steps to go through to create these models, and I'm just going to take you step by step through that process. So you're able to name the regression model. So we've named that there. You've got to save this down to an area within your portfolio tree. So I'm saving this down to the International Brewing Company. And then you want to either create a new model, replace the current model, create that new revision, or you can ignore that entirely and have an additional model. And then we'll just simply hit next. And then this takes us to the dependent meters area. So we're trying to select the dependent meters, and this is going to be how many models are created within this configuration. So again, what I've done is I've gone into the path, I've selected the International Brewing Company, and that's then applied into the list view here. And then you're able to define further via tags. So any meters that have got the electricity and the low frequency tag, I've added into this, and then you can actually check the matching meters as well. So we've just hit in there. We've got 9 meters within this view, so 9 regression models are going to be created in this one configuration. So then we go to the next step, and this is the independent variables. So you're able to add a number of different variables, up to 20. They can be related consumptions, so you just select another meter within your portfolio tree. They could be meters by tags. So again, you can get quite clever with your portfolio, and then you can pull in some meters that are tagged essentially. We can add in degree days, time, active hours, And if you're looking at, say, projecting this dynamic target into the future, you could have meter budgets, which would allow for regressions to basically do some forecasting. So I've picked my independent variables. I've got them all listed there. And then what I can do is go to next, and then this is where we're looking at the training data. So this is where sort of the machine learning comes into play. You've got your initial training data set. You can, from the data exclusions, train that data and then make that more applicable for the regression. Within here, we've got other options as well. So you've got the force intercept through to 0. So this is if, for example, you're building a regression and say it's a manufacturing site. If you're not manufacturing anything, any production, and there's no base load, it does actually go to 0. You've got the option to have that in there. We're also able to add a threshold for the R² value. I've got this in as 0.5. Typically, this would be 0.7 or even 0.75, just to apply it to the IPM, VP, and ASHRAE guidelines, the thresholds there. But essentially, what you're doing here is enabling ones that are within that threshold. Everything else that's not within that threshold will not be enabled as a regression model, and then you can deal with those later and have a look at why there's not a good correlation. We've also got a validity period as well, so you can either have that as an annual period, or you can do custom months as well. So again, adding that seasonality to that. So you might have different seasons and different regression models to suit. And then I hit next, and then we're going to review. So basically what we'll be doing now is hitting save and finishing. For time's sake, I'm not going to do that. However, what I'll do is show you the notification screen. So basically what will happen, if you save that down, that'll then start the process as a background job. So you're not sitting there waiting for that job to finish. You can get on with other analysis that you so choose. What you've got in the user panel here is notifications. So what we will see is, and again, I've got no notifications in there at the moment, but what you can see is the notification will come in, say that that's then been finished, and then you can go to sort of that next step and start analyzing those regressions. So if we just jump back into mass edit regression models, and what we're going to do is validate one of these regression models. So the one I was in was this one here. So we're just going to hit validate and go into this. So we've got all the regression models that have been set up. We're going to jump into, let's go into this one, Berlin. So straight away, you can see some of the insights. We've got the R² values and the CV values here. Something that's new is this pie chart. So what this is doing is showing you the individual contribution of that driving force. So in that example there, we've got the meter for CO2. That's providing quite a big impact to the consumption for this particular meter. Again, what we've introduced as well is the weekday contribution. So we've got a number of different driving factors in there. And what we can do is look at the full regression. So we can just click on this icon here, and that'll take us to the full regression. So just looking at the top graphic, this is the blue is actual data versus the predicted usage model. So if you're if the blue line's above that black line there, then you are not actually hitting your best practice. So again, investigation might be required at that individual site, but it's a good telling factor. Again, within each site, you can add alarms to understand if you're going outside a certain threshold against an MV alarm model. So you don't need to be in the system all the time. The system can tell you. Below in this graphic here, we've got some CUSUM analysis, so really giving you that performance across the period. So we can see sort of by the end of the period, we're actually pretty good against the model here. But again, this is demo data, so it might not be the typical view. You're able to change the view in terms of the categories underneath here and the icons. So you can change that view. You can change the interval as well. You can also chart the data underneath, so you can actually see the data there that presents underneath. So you can see the differences and then the cumulative difference as well. So let's just go back to summary. So that's the full regression model, taking into consideration all of the variables. What we want to look at now is an individual contributor. So I mentioned the CO2 meter earlier was a big contributor. We can actually go into the correlation of that as well. So this then provides a scatter plot, and you can see some outliers here. We might want to refine this model. So we could go to the data exclusion bit, which I'll show you next, and you could actually just exclude those points. We've also got the CO2 consumption versus the expected consumption as well. So you can see how well that's performing against that single regression. And again, you've got the chart data that then falls underneath. You can see that there. So let's just jump back to summary, because we're going to then go into data exclusion. So we'll just jump into here. So within data exclusion, you're able to pick your driving factor, and then you can then start setting rules. So you can have, greater than or equal to, less than or equal to, equal, not equal, and then inside and outside of a range. So you can get very clever with refining that model. And again, you can apply that to the regression, and that then can be that sort of next variation of that regression model. And then after that, what you're able to do is pull these reports into, say, your dashboard. So where you've got your central point of all data. And I want to do is just quickly show you that as well. So if I just jump into dashboards, these are called the facilities management dashboards. This is my private dashboard, so I've just got a number of different energy analyses in here. But for today's purpose, what I want to do is just delete a couple of widgets here, and then I want to pull through the MVLR or the regression model into here. So I'm just going to add in, and it's all drag drop, and we can sort of resize these, but I'm just going to make this a complete graphic. I'm going to add another one as well and put that in there. So what I'm going to try and pull through is the MVLR consumption graphic and then the CUSUM underneath. So I'm just going to go into open configuration, and this is very wizard driven, so it's easy to use. We go into analysis. We'll need to find that analysis type that I'd sort of configured earlier. So I'm going to go MVLR Berlin, I believe it's under. And there we go. Okay, so I've got the consumption one there. I'm going to put template period just to make sure that there's data in there, and that will then pull through. So then I'm going to jump into the next one, and I'm going to then pull this through as well. So we're going to go into the path. I'm just going to put MVLR Berlin as I did before, and then I'm going to pull the CUSUM in, and I'm going to have that as a template period just to make sure that there's data in there, because again, this is demo data. So what we've got here is the blue line is the actual, and then the green is the predicted, and then we've got the CUSUM underneath for that. So again, you could have this presented on a dashboard. If we just hit full view now, you've got that dashboard, and look, I didn't pull that down, but they're very configurable, these dashboards. You can add MVLR models on here. You can have all sorts of different widgets. So again, just as another example, I've got one based on lots of totalizers. So we've got electricity, gas, water, showing the consumption of last week, cost, CO2, and then we've got some sort of 24-hour widgets as well that have got thresholds. But there's lots that you can do in here. So what I'm going to do is just go back to the presentation. I've got a few more slides to share just before we go into questions. So in conclusion, in terms of tying those independent variables and using them to be able to create those relationships, that's where we're able to do. So we're pulling in those independent variables, but we're able to do them en masse and do them at the same time, as well as being able to tune them with a single click of a button through the data exclusion and redefining that training data. In terms of visualizing those correlations that match up and how the actual may be deviating from best practices, of course, we can measure those deviations. We want to maintain that relationship and understanding of how all those variables are contributing to the overall model, which we can do, and be able to evaluate those contributions. Are there times where we want to switch out due to a poor correlation? So, for example, between one of the variables, which we're not seeing usage follow the water usage. So it may be water not indicating properly the building population. Or it could be the windows are so good that the solar irradiance is less relevant in regards to the air conditioning needs. These are all factors that could be considered. So in the time allocated, I hope that's given you a bit of an insight and highlights when it comes to regression analysis and how eSite are able to provide tools to enable companies to monitor and reduce energy consumption, or at least have an understanding that the consumption is not at the correct level, and then there are steps that can be taken to reduce that consumption. So thank you very much for your time, and it's been a pleasure to speak today. I think we need to move on to see if there's any questions that have been raised sort of during today's presentation. So thank you very much.
Thank you. Also from our side, Kyle, thank you very much for your presentation. It was really informative, and the amount of data that you've shared with us, I think it's a combination of IT, electrical system engineers work, and surely as electrical engineers and all other disciplines, electronic engineers, this is really what we want. I've got also a few questions. I think we've got Dr. Stevens, who will be assisting us as well. And I don't know, Dr. Stevens, do we have questions so far? I know it was maybe we upload with the presentation from Kyle.
Yes, thank you, Shepard. Yes, I just have a few questions. The first one, Kyle, are you doing eigenvalue analysis to see the actual impact of the particular variable on the outcome? In other words, if you're looking at 20 variables using eigenvalue, you can see which is positive, which is negative, and the value. Are you doing that, or is it just straight regression, linear regression?
Yeah, so I guess at the moment it's straight linear regression. So it's using the multiple factors. In terms of the exclusion rules, if it is going into a negative and you want that to be excluded, that can be done to sort of fine tune the regression model. Mm-hmm.
And the independent variables, how do you test if they are actually independent? For example, water could be a function of temperature, or it could be a function of something else, which is also dependent on, which also affects some of the other variables. Do you do tests on the independency of the variables?
Yeah, so I guess in terms of eSite service, this can be a software platform that customers take and go away and they do their own regression models with their own knowledge. But also what we can do is consultancy, and within that consultancy we will be understanding the client's process from start to finish. So we're responsible then for getting the correlations and understanding those, and then we're applying that to the ASHRAE and the IPMVP guidelines. So you can see there that any correlations that are sort of below that 0.75, they won't be enabled as a regression model to be able to analyze. You will need to work with that model further to make sure that is a good correlation before being able to make that regression live.
Great. And then this particular model, this type of theory can be used in a number of industries. Are you limiting yourselves only really to lean energy or sort of carbon reduction, carbon dioxide reduction, or are you looking at other industries as well, relating to production, production of materials or products?
Yeah, definitely. I think the two examples as part of the presentation. I think in terms of production, that's an easy one for people to follow. In the understanding of the property management, it could be a number of people within a building. So it is cross industry, but I think in terms of key case studies that we've got at eSite, it does apply very well to the manufacturing sector. However, it doesn't mean that it's only utilized in that sector. eSite is very, very configurable, so it does work with sort of any sector, as does the regression models. But again, you'd need to sort of analyze and understand those driving forces to make this work.
Great. Shepard, there is one question here from Ken Brown. What does IPMV stand for?
IPMVP, so it's the international, so that's a very good, so it's the International Protocol Verification Measurement and something, but I can provide that afterwards if you want. So it's an international guideline basically for regression models.
Madam. Okay.
Thank you. Shepard, Chair, that's the end of the questions as we have it at the moment. So I'll hand back to you. Thank you.
Thanks. Thank you, Dr. Stephen. And then maybe one or two questions, Carl, from our side. You've actually mentioned that you can add up to about 20 variables. And also you've used variables and drivers interchangeably. In terms of your drivers, what's the limit there? Or is it more or less one and the same in terms of your approach? I know there's sometimes issues with your energy performance, and you might need to look at quite a number of drivers. Is there any limit there, or how does it work out on your system?
Yeah, so I guess within eSite, what you're able to do is create meter types, so you can have any drivers, driving forces going into the system, whether that be production, humidity, degree days, building population. These can be added in as meters, and then they can be used in the regression model. So within a single regression model, you can have up to 20 drivers, but it's not to say that you've got a couple of models that are working side by side with other drivers. So again, it would be quite a feat to get 40 driving factors for that one dependent meter. But again, we've allowed up to 20 because what we did see with clients before this release was that they were starting to add, especially our more complex clients, they're starting to add that day of week sensitivity, and this required more very independent variables to be considered.
No, great. And then the other one, it's more on the communication protocol and maybe the platforms that you use. I like the your dashboards there. What capability does your system have in terms of now communication this data? Can it be linked to some of the social media platform? Can I see some of the info via now SMS is no longer an option, it's WhatsApp and all other platform, emails and all that. How does it work? Or do I need to be live on the platform before I can see any stats?
Yeah, so with the Express user interface, that downsizes quite nicely on a smartphone. If you're looking to integrate eSite or eSite's data with another system, then we've got APIs available, so clients can pull out the information via web services. We're looking to make more integrations with that as well. So an example of that could be that you might want to be sending alarms, and the alarms could be related to these regression models, to workplace order systems. And then that will then provide a work order for an engineer to go out because the boiler is inefficient, and they can then go and do that. So we've got integrations like that we're looking to do, and that will be via APIs with the alarms. So yeah, there's lots of ways that you can integrate the system. Again, data coming into the system, just to give a brief on that as well. You know, we can bring data in via IoT. We can bring data in with the next release. Actually, we can pull data from other systems via API using our interface. So it's going to be a bit of a game changer actually in terms of that collection of data, which is, again, for all clients, you know, data is key, and it's being able to get access to that data. And this API collector service is going to be very, very game changing for eSight for that, and it's going to make it far easier for clients.
No, great. Thanks. Thank you so much for this information. I think there's a lot that you know, your system can be used, your platform can be used for. I mean, on property side, you know, you can manage the entire property or real estate space. The energy side, if you look at the energy, there's issue with water, there's carbon issue, and I think there's a lot. I'm pretty sure the audience also in connected online will agree with me that we've got a lot of services that we really need a system similar to this, where we can manage and show live data and be accurate on our analysis, especially that you use the lean approach. I think I like it. It is one of the practices that has, or method that has been tested, and it seemed to be still the best, and the regression is still seemed to be the best approach that we can consider. Thank you so much for this presentation, Kyle, and to the audience as well. We thank you all. We thank you all for your attendance, and we invite you to go to our web page address, which is www.saie.org.za for more information there. The webinar is closed. Thank you very much.